All right, it is time for us to look at the 8-4 worksheet, all about the law of cosines. Starting with number 13. How is the law of cosines used to find a missing angle measure if the side lengths of a triangle are given? So when we have the side lengths, but we're trying to find an angle measure, we need to first set up an equation with a missing angle measure and then solve that. So we're going to say, let me get my pencil on here. We're going to say you set up an equation with the missing angle measure. Set up an equation, that equation being the law of cosines equation, with the missing angle measure. And then solve the equation for the cosine of the missing angle. And then solve the equation for the cosine of the missing angle. Then, once we have like the cosine of the angle, the cosine of x equals blank, we have to take the inverse cosine of the result to get the angle measure. So then, you take the inverse cosine of the result to get the angle measure. And there you have it. Oops, should be a period, not a comma. All right, let's keep going. Number 14, Tevan is asked to find EF. What error did Tevan make? So when he was going through, he ended up dropping off the squared that was supposed to be there. So he's still left with EF squared instead of the length of EF. So he forgot to take the square root. Tevan forgot to take the square root of the answer, which is about 6.99. Let's keep going. This is an interesting one. Suppose you know 2 of the side lengths of a triangle and the measure of 1 of the angles. How do you choose whether to find the third side using the law of sines or the law of cosines? Well, let's draw ourselves 2 diagrams here. If I know 2 sides and a not included angle, that's one of my possibilities. Or I could know 2 sides. I don't want to make that a right triangle. That's confusing. I could know 2 sides and an included angle. So the included angle between the 2 sides. Those are my 2 cases. If I know an angle side pair, if I know an angle and the length of the opposite side, I want to use the law of sines. But if I don't, the law of cosines is going to include all the information that I need. So use the law of sines if you know a side opposite a known angle. You know a side opposite a known angle. Otherwise, use the law of cosines. Otherwise, use the law of cosines. There you go. So sines for a problem like this and cosines for a problem like that. All right, we've got this triangle. If I was given side length A, B, and C, how would I find the measure of angle A? So this is kind of like question 13. We would need to use the equation that would allow us to find the cosine of angle A, and then we would take the inverse cosine of what we found. So the equation would be the version that is a squared equals b squared plus c squared minus 2bc rather, bc cosine A. And that would allow us to find the angle A. Then we would find the inverse cosine of the result. So we'd solve for cosine of A. Then take the inverse cosine of the result. Of the result. If we were given the measure of angle A, side B and C, and we needed to find side A, we would actually use the same equation. But all we would need to do once we got A squared on its own would be to take the square root. So we would set up the equation. A squared equals B squared plus C squared minus 2bc cosine of A, and solve for A squared. Then find the square root of the result. All right. Number 20, find x to the nearest tenth. So we're just using the law of cosines here. So we're missing that x, but we know it's opposite angle. So x squared equals 13 squared plus 21 squared minus 2 times 13 times 21 cosine of 83. And if we solve that all out, use a calculator, we get x squared equals 543.46. Take the square root of both sides, so x equals 23.3. Number 21 is set up the same way, so we can use the same idea there. X squared equals the other two sides, 13 squared plus 15 squared minus 2 times 13 times 15, cosine of the angle we know of 23. Put that in your calculator, find that x squared is equal to 35. Take the square root of both sides, and x equals 5.9. Again, we're going to the nearest tenth. Down here in 24 and 25, we have a slightly different scenario where we have all three side lengths and we're needing to find an angle. So we will start the law of cosines with the side length opposite the angle. 19 squared equals 11 squared plus 22 squared minus 2 times 11 times 22 cosine of x. And then when we solve that, that gives us 361 equals 11 squared plus 22 squared is 605. Minus 2 times 11 times 22 is 484. Cosine of x, again, I'm just simplifying and solving. So then I'm going to subtract 605 from both sides. Negative 244 equals negative 484 cosine of x. And then I'm going to divide both sides by negative 484. And that's going to give me 0.504 is equal to the cosine of x. I've got to take the inverse cosine of both sides to find x. So the inverse cosine of 0.504 is equal to x. Inverse cosine of 0.504 is 59.7. So x is 59.7 degrees. Number 25. We've got the same scenario there. Start with the side length opposite the angle. So 23 squared is equal to 22 squared plus 16 squared minus 2 times 22 times 16 cosine of x. And then we solve. So we've got 529 is equal to 16 squared plus 22 squared is 740 minus, and then 2 times 22 times 16 is 704 cosine of x. Then subtract 740 from each side. We get negative 211 is equal to negative 704 cosine of x. Divide both sides by negative 704 and we get 0.299 is equal to the cosine of x. Take the inverse cosine of both sides, and that is going to give you 72.6 equals x. There you go. Down here, a golfer hits from the tee for a 300-yard hole. Her drive carries 275 yards, but is 13 degrees offline from the hole. How much farther must the golfer now hit the ball to reach the hole? So we're just finding the distance x. We know the other two side lengths and the angle across, so we can use the law of cosines. X squared is equal to 300 squared plus 275 squared minus 2 times 300 times 275 cosine of 13. Lucky us, we can put all that in a calculator, and we find that x squared equals 4,853.9. Take the square root of both sides, and that's x equals 69.67 yards. Number 13, a triangle has side lengths with lengths 12 centimeters and 15 centimeters. The measure of the included angle is 46 degrees. What is the length of the third side to the nearest centimeter? Same as the question above. We would set up the, you might want to draw this for yourself if you need, but we would set up the triangle. We've got 12 and 15, and the included angle is 46. We want to find the opposite side. So we would do x squared equals 12 squared plus 15 squared minus 2 times 12 times 15 cosine of 46. And when you put that into your calculator, solve it, you get 100 and something really small. Take the square root of that, and we get 10.9 centimeters. Number 31. An architect proposes the plan shown for a new roof with a 40-degree incline on one side. The owner of the house thinks that 40 degrees is not steep enough and wants the incline to be 50 degrees instead of 40 degrees right here. If the length of the adjacent side does not change, by how much does the length x feet of the opposite side increase? What is the new angle of incline for the opposite side? So we've got a lot going on in this one. Sorry, I had to get a popcorn out of my teeth. So what we're going to do first is we're going to find the length of the side x such as it is now, using the law of cosines. So x squared equals 16 squared plus 20 squared minus 2 times 16 times 20 cosine of 40. That is going to give us x squared equals 165.73, and then we can take the square root of that and get x equals 12.87. So right now, there's 12.87 feet right there. The question that we were asked is, if we make this angle 50 degrees instead of 40, how much longer is the opposite side, is side x? So let's redo this with a 50 in here instead of a 40-degree angle. We'll change our color here for good measure. So we've got x squared equals 16 squared plus 20 squared minus 2 times 16 times 20 cosine of 50. And then we'll go ahead and solve that. We find that x squared equals 244.61. Take the square root of both those sides, and we get x is equal to 15.64. So then it just asked how much longer is the side length. So that would mean we would do 15.64 minus 12.87, and it is officially 2.77 feet longer if we make that roof 50 degrees of incline instead of 40 degrees. But it wasn't done, because it also asks us, what is the new angle of incline for the opposite side? So if we have a 50-degree angle of incline over here on the right, what is the new angle of incline on the left? Let's find out. Let's redraw that roof down here. We have not 2.77, sorry, we have 15.64 over here. We just calculated that. We still have 16 on this side and 20 on this side. And we have 50 that we know right there. And we're trying to find x, the other side angle of incline. This is a problem where we happen to know an angle opposite side pair, which means we can use the law of sines to get this problem done much easier by saying the sine of 50 over the opposite side, 15.64, is equal to the sine of 16 over the opposite angle, not 16, sorry, haven't done this in a minute, the sine of x, the opposite angle, over the opposite side, 16. Then we cross multiply, we learn that 16 sine of 50 is equal to sine of x, let's see, 15.64 sine x, sorry. 15.64 sine of x. We're going to divide both sides by 15.64. And we get the sine of x is equal to, the 16 sine 50 over 15.64 is equal to the sine of x. And we can actually take the inverse sine of both of those numbers. So the inverse sine of 16 sine 50 over 15.64 is going to be equal to x. That, oops, I run out of room, hold on, let me move this up. There we go. So that's going to make x equal to 51.6 degrees. There you go. Number 32, which equation is true for the triangle shown? We just have to pick the one that's going to help us solve for side A. And of course, that one is D, using the correct arrangement of the law of cosines. So hopefully this helped you. Now we will move on, and I will go ahead and record the 8-5 worksheet answer key, and you can have a wonderful day.